Good day. Today we are going to discuss about fuzzy logic and neural network. I am Dr.M.K.Illampoornan, Professor Electrical and Electronics Engineering from Bharat Institute of Higher Education and Research. Having discussed about the fuzzy logic, today we will discuss about the neural network. The artificial neural network as it is designed for mimicking our human neural network. So in order to understand the neural network, we need to go to the fundamentals of a human neuron, which is working as a network to process various information. Before that, we will have a small introduction on the neural networks concept. It is very exciting method and an alternative method for solving various problems in different fields of science and engineering. We have to discuss about what is the holistic idea about artificial neural networks and also the motivation for artificial neural network development and various architecture and learning models. There are certain important use of artificial neural network that also we will discuss in the due course. First, the origin of a neural network. Human brain has very high potential and incredible characteristics such as parallelism, that means parallel thinking, and distributed representation. We can conceive many ideas from various aspects in the form, in the taste, touch simultaneously. That is very difficult for any system to do it. Similarly, we can conceive of various computational techniques, and we can even keep that and further improve it by learning. Then we can take a small studied object and we can extend it for various objects which are very new by simple principle of comparison. And similarly, the human brain has a very great capacity of adaptivity. That means if it encounters into the new situation or a new problem, it can turn its memory pages and compare with what is existing while learning, and then it comes to a particular conclusion based upon its memory, learning as well as new circumstance, and adopt a new solution for it. That is a great capacity of a human neural network. Uh, our computer scientists have tried a lot to mimic it, and it is their dream to create a computer which exactly replicate humans capacity, but it has a lot of problems in development as well as making it a wide known and solving project or element. It is very difficult for them. So there was an attempt to do it first mathematically. So artificial neural network models was an effort to apply some method, not all the methods of human brain, but some methods of human brain to solve certain unique problem. Either it may be a visual problem or it may be a audible noise problem or anything in mathematics. Like that, they tried various aspects of human neural networks which will be able to solve in a machine learning network. So the first such attempt was made in 1940 by McCulloch and Pitts. It was a very initial time where he tried to devise a model which will almost mimic the human neurons. Then later in 1960, Rosenwald introduced a model which is perceptron model, which is widely known and it is used. It has its own method of learning, and it has that learning methodology given by convergence theorem. And there was certain small improvement which was made by Minsky and Papert. There are certain limitation which was actually pointed out in Rosenwald perceptron model by certain specific example that also we are going to discuss. After a long gap, because of that particular perception of a problem, there is a long gap of 20 years. In 1980, we were able to solve that Minsky-Papert problem using half-field networks, and there was a approach which was used to solve, that is half-field energy approach, and there was an algorithm which was used, that is called as back propagation algorithm. In order to understand the neural networks, first we will discuss about the biological neural network. In this, we have to understand first of all what is neuron and its elementary parts. So the neuron contains the dendrite. The dendrite is a point where input from another neuron is received. So there are various dendrites. You can see the dendrites on the side of the main body, that is called as soma. It is also called as cell body. After receiving all the input, that is from the other neurons have their end part, that is synapse, connected to the dendrites. So what is the means of communication? That is actually by releasing a chemical that is known as neurotransmitters. So another neuron will communicate to this neuron via the synapse to this neuron dendrite. So all these potentials were gathered, and there was a threshold which was there to assess whether the signal has to pass through the cell body to axon. That threshold is determined uniquely based upon the learning as well as the previous acquaintance. Then it is taken as an electrical signal to the axon. Through the axon, the electrical signal was communicated to the synapse, where the synapse again releases a chemical which is the neurotransmitter. So thereby you can understand the information pass from the synapse of other neuron to the present neuron dendrite. You have a cell body in which all the potentials are collected, and there was a threshold which will determine whether further processing of information should be there. If it is beyond the threshold, the information will be passed. It is passed as electrical signal to the axon. From the axon through the synapse, the chemical transmitters are available, which will be connected to the next neuron. Like that, you will have multiple connection, and you can see a sample of the picture which is taken, and this is a model which will be explaining you how this connection between an axon, synapse and dendrite is there. So this is a cell body, and this is also another cell body. You can see that synapse are always connected to the dendrites. A brief summary on how the neural network works. We have the signal which is reaching the synapse, and there is a chemical which is transmitted, that is called as a neurotransmitter, and there is a process of learning. The synapse effectiveness can be adjusted by the signal which is passing through. So that is actually taken as process of learning. Then if you know about our cerebral cortex, you can expand it as a flat sheet of neurons which is about 2 to 3 millimeter thickness and 2200 centimeter wide. You can have almost like 10 power 11 neurons. So that is the power of human cerebral cortex. Duration of the impulses between the neurons was almost like millisecond, and amount of information sent is also small, that is around a few bits. The critical informations are not transmitted, but they are stored in the interconnection. That is the beauty of the human neural networks. So that is a memory which is also taken care, as well as processing which is also taken care. That means if you are discussing about the processing, we will have our human brain working as a intellect, as a deciding authority. Whereas if you are speaking about recognition or recollection, it will be taking from the interconnection storage. So it is the beauty of the human neural networks. So mimicking it will be very Herculean task, which we are going to, or we are attempting with various network types. There are certain models which was named as connectionist model, which was actually initiated from this base. First, we shall study about the very fundamental model that is called as McCulloch-Pitts model. It was named because of the first scientist who has given this particular model. So it is almost similar to our human neuron. So when we compare the human neuron, this is the input which we are going to take, that is from x1, x2 to xn. These are the input we are going to take. You can compare this to the neuron or neural transmitters. Then it will be given as an input to the dendrite of the another neuron. Then you will have the weight which is based upon the learning of that particular neuron. We determine how much amount of the signal will be passed on to the body. That means here represented with a huge round, that is a neuron. After accumulating all the information, you can see here there is a summation which is done as a product of input and the corresponding weight. You will have to pass through the output. That is almost like an axon connected to the synapse, where you will have a threshold which will determine whether it will be again emitted out through the synapse as a transmitter. So here you have the various signals which was used as a threshold. The next significant model in the path of artificial neural network was given by Rosenblatt perceptron model. Actually, the model was developed over the years by Rosenblatt and Selfridge. They have generalized the McCulloch-Pitts of linear threshold law, and they have given some other learning law which we will discuss in due course. Actually, the impinging of the neuron was computed, and the firing of the neuron was determined by the weighted sum of the input. In the earlier days, the neural network modeling was given very much attention because of McCulloch-Pitts model, but there was some issue in developing as a system. So they need a learning approach. Since Rosenblatt has given both the model and the learning approach, and also there is a learning law which was given by Hibbs, Donald Hibbs, which was incorporated into the perceptron model. It has become a complete practicable, or we can even install in a particular system which can function on a given instruction. Hence, Rosenblatt perceptron is a practical model compared to theoretical model of McCulloch-Pitts. But anyhow, that is a base for Rosenblatt perceptron model. So, what is the uniqueness of the Rosenblatt perceptron model? Is you will have a learning rule as well as an approach. The learning law was given by Donald Hebb. It is also called as Hebb's law. And there are different types of threshold which is available for this functional model. You can see here in 1962 Rosenblatt gave this perceptron model. It was originally conceived with an idea as a pandemonium by Selfbridge. These modelers have an adaptive network which will adapt to the given environment very quickly. So that is the uniqueness of this these models. Rosenblatt has developed a network architecture and successfully implemented various architecture into it, which will make and learn the choice of different patterns which is given as an input. It may be a sensory stimuli also. Regarding the Rosenblatt perceptron, we have the following properties which we can discuss in detail. So the properties are listed here. The first one, it can receive input from other neurons. That means the neuronal connectivity is possible in the perceptron model. Second one, the received neuron or the recipient neuron can integrate the input which was received from various neurons. The connection of weight will be as given. The Xi is the input which will simulate provided the weight is positive. Similarly, Xi is the input which will be inhibited, which is represented by a weight which is negative. So the third characteristic is very important characteristics which will indicate whether the input will be received in a proper manner and it will be passed on for the summation process. So it will be reduced signal or increased signal which will be determined by the sign of the weight. Then fourth property is output function of neuron is 1 or 0. That means it is having some output or it will not have an output. So yes or no, like binary output condition. Then a learning process can be modified by adjusting the weights. So we can see some samples whereby we can adjust the weight which will improve the learning of the model. The Rosenblatt early example of the so-called electronic neuron was actually a mimic of biological neuron. It has the following property. They were having certain magnitudes of signal. Instead of neurotransmitter, here we use electrical signal. The inputs was given as x is equal to from x1 to xn. Next, the recipient electronic neuron can integrate. So it is a mathematical function. So it can integrate by simply adding all those inputs multiplied by the corresponding weight, which indicates the strength of the connection. Thereafter, it will pass through a filter, which is we are calling as threshold. So this is the typical thing in Rosenblatt perceptron. So there is a small note which we have to discuss here. This is the summation function. The g of x is the summation function. That means we will get a weighted sum. Say for example, you have two weights and two input, w1 into x1 plus w2 into x2 is a summation function which is described by g of x. So this will have a specific output. Say for example, if weight is positive, both will be additive. If weight is negative, then there may be some cancellation in the input. It has to pass through the threshold for it to give an output. As we have discussed earlier, this electronic simulated model will also have a weight which is positive, which will enhance the input, or the weight is negative if it needs to inhibit the input. Of course, you know that the digital functioning. So here the electronic will be mostly an output of a gate, which will be either 1 or 0. There are certain plasticity which is available here to modify the weight, which can be compared to the learning of that particular model. Rosenblatt was very serious about using this perceptron incorporated in a computer systems. So there will be a kind of incorporation. First, we have to use the gates, which is having a specific input and a specific output. So if the gate could be implemented in the Rosenblatt perceptron model, that means you can use that model for the entire operation of a system. This is the basic idea I am emphasizing here again. If a particular model, especially the Rosenblatt perceptron model, able to mimic the gate functionalities of input and output, then it will be, or it can be used for building the entire computer system. So initial attempt was made by the Rosenblatt in order to function as a particular gate. Say for example, he has modeled the Rosenblatt perceptron mimicking the AND gate, and also he has tried for OR gate. So all these things is an evidence which is used for making it a unique product which can be incorporated into the actual existing system. We shall discuss about the Rosenblatt perceptron model with an example. So before entering into the example, first let us give the algorithm for calculation. So the algorithm for the single layer perceptron is given as follows. First, we have to train it for a number of epochs. Epochs means we have to present the input given set of times. You cannot take a particular input and present it twice in the same epoch. So you will have a batch of inputs which will be provided in a different epochs. Next, the initial weights were assumed arbitrarily, and also there was a threshold which is assumed. So all these three are assumption, and it should be a realistic assumption. We will have, apart from that, a learning rate which will be assumed, known as alpha. The second step, there will be a computation of the weights and its product with the input. Say for example, if you have two weights and two inputs, the product of two weights and two input correspondingly will be x1 w1 plus x2 w2, and there will be a threshold added, that is theta. So x1 w1 plus x2 w2 plus theta will give a value. This value will be passed on to a function which is a delta function. The delta function will be giving an output of 1 if the total weighted sum along with the threshold is greater than 0. It will be giving an output of 0 if the weighted sum with the threshold is less than 0. So that is a very important thing which we need to understand before making the model learning. Then the fourth algorithm is the error is calculated by the difference of the desired output to the actual output we have calculated by using step 1 to 3. Then we have to adjust the weight for further learning. The adjustment to the weight or the new weight which is given by Wj of I plus 1, which represent ith iteration. The Wj of I, which is the old weight, is added with product of alpha, which is learning rate, xj, the old input, and then error. So the new weight is given by old weight plus product of learning rate, old input, and error. So these are the steps which we need to follow for the perceptron to learn. In order to understand the learning of Rosenblatt perceptron, we shall take the AND function. We know the truth table for AND function. The truth table of AND function is given by when we give two inputs as 0, the output will be 0. When we give one of the input as 1, either 0, 1 or 1, 0, the output is again 0. When we take both the input as 1, that means AND condition is satisfied. So we will have the desired output of 1. So this is the truth table of AND, which is incorporated as input and the output desired. The input is given by x1 and x2 and output desired is given by y desired. The learning rate is fixed. It is given by alpha is equal to 0.1. The threshold is given as minus 0.2. Initial weights were given and it is assumed arbitrarily as 0.3 and minus 0.1. That means the first input is enhanced, which is given by a positive value of 0.3, and second input is inhibited, which is given by minus 0.1. Actual output, what we will be getting will be 0 into 0.3, 0 into minus 0.1, which will be 0, and minus 0.2. So if you do all these things, you will have minus 0.2. You can verify to the delta function. Delta function will be 0 if the actual output is less than 0. Here we are getting minus 0.2 because 0 plus 0 minus 0.2 will be minus 0.2. So output will be 0. If we compare the error, y desired is also 0, output is also 0. So we won't be getting any change. So there will be no change in the weight too. So the weight remains same. The same thing occurs for the next one, but with a little bit different. 0 into 0.3 will be 0. 1 into minus 0.1 will be minus 0.1. Added with the threshold, which is minus 0.2, you will get minus 0.3, which is again negative. So actual output is 0. So there will be no change in the weight. If you take for the next input, that is 1, 0, we will have 1 multiplied by the weight 0.3, 0 multiplied by minus 0.1, that means you will have 0.3, added with minus 0.2, you will get plus 0.1. That means that you will have a positive number. According to our delta function, if you have a positive number, we will end up with the output of 1. So actual output is 1. What is error? Is the difference between the desired output and the actual output. So we will have an error of -1. Now we need to adjust the weight. So how we can adjust the weight? We have the formula. So old weight. So where the adjustment has to be taken for both the things. So old weight is 0.3 plus alpha, that is 0.1, multiplied by the input, that is 1. 0.1 into 1 will be 0.1, multiplied by the error will be -1. That means -1 into -0.1 will be -0.1. If you add with the initial weight of 0.3, you will get 0.2. So there is a change in the weight. If you do it for the second weight, you will not be getting any input. There is a change because you will have alpha 0.1 multiplied by the input, which is 0. And there is of course an error 0.1. If you multiply, it will be 0. So it will remain as the old weight, that is minus 0.1. Now, what is the important rule here we need to follow is, whatever the weight we have got for the last one, we have to add for the new one. That means a new weight, initial weight will be 0.2 minus 0.1. Now, if you multiply with the input 1 into 0.2 will be 0.2, 1 into minus 0.1 will be minus 0.1. If you add it with the threshold, you will get 0.2 minus 0.1 minus 0.2, which will be minus 0.1. So output will be 0. That means that error is positive. If the error is positive, what you have to do? Again, we have to do the same formula. Take the old weight, that is 0.2, add it with the product of alpha, input and error. So 0.1, 1 and error 1 will be again 0.1. So 0.2 is added with 0.1, that means 0.3. Whereas here there is a significant change. So this weight is minus 0.1, alpha is 0.1. 0.1 multiplied by 1 will be 0.1. Error is plus, that is 1. So you will have 0.1. 0.1 plus minus of 0.1 will be 0. Such that we will get the final weight. Taking the weight from the previous epoch, that is 0.3 and 0, we will have to continue with the next epoch, that is next set of input for the AND gate learning. Here the first inputs will not have a change in the weight because there is no error. If you go for the third input, that is 1 0, we will have the multiplication. 1 into 0.3 will be a positive number, minus 0.2 will have a positive number. So the output is 1. But actual desired output is 0. So 0 minus 1, you will have an error minus 1. So what we need to do? We need to alter the weight. So how to alter the weight? We have to follow the formula. That is the learning rate 0.1 multiplied by the input 0.1 or 0.1 into 1 and multiplied with the error, which is minus 1. So minus 0.1. If you add 0.3 with minus 0.1, you will get the final weight of 0.2. The second will not have any change because the input is 0. It is 1 0. When we come to the third one, we have to take the initial weight as 0.20. If you do it for the fourth iteration, that is 1 1, multiplying this one, we will be getting 1 into 0.2, 1 into 0, which is 0.2, threshold is minus 0.2. If you add, you will get the 0. 0 can be considered as equal to 0, so the output will be 1. There is no error in it, so there is no change in the weight. Further continuing, in the third epoch, along with the last iterative weight, that is 0.2 and 0, first two input we won't be having any change. The third input we will have 1 0 multiplied with 0.2. So 1 into 0.2 will be 0.2 plus 0 plus minus 0.2, which will be 0. Output again becomes 1. So the error is also minus 1. What happens? This will lead to the reduction in weight, which is actually calculated 0.1 into 1 into minus 1, that is minus 0.1. Adding with the initial weight of 0.2, you will get 0.1. The second weight will not have a change, 0. So transferring this final output of weight, which has been learned, into the fourth input, that is 0.1 and 0. If you multiply, you will get 0.1 into 1, and you will get actual output of 1. So that means you will have the error, which is again positive. So it will be transformed into 0.2 and 0.1. Continuing with the fourth epoch, with the previous iteration of weight output, that is 0.2 and 0.1. First two input, we won't be having any change. The third one, negative error. So 0.2 and 0.1 change in weight as 0.1, because this 1 into that 0.1 into minus, negating 0.2 with minus 0.1, you will get 0.1. The second weight will not have any change, so it is continuing as 0.1. Transferring this for the fourth input, you will have 1 into 0.1, 1 into 0.1, that will be 0.2. Threshold is 0.2, which is in minus, so we will have output 0, which can be considered as positive. So the actual output is 1, which is what desired, so there is no error. Continuing in the same way for the epoch 5, you can see here the errors are not there. That means we have reached the final stage of iteration. So what is the final iteration stage? We have got the weights as 0.1 and 0.1. That means the Rosenbald perceptron model has learned the AND gate. Its threshold is 0.2. But what will happen when we go for XOR gate? It is impossible for single layer perceptron to solve this problem. We can solve any problem with single layer perceptron model, provided the output are segregated in the plane where the zero value is obtained by a line to the value of 1. Since in XOR gate you cannot do with single line such a separation, it is impossible for Rosenbald perceptron model to solve such a problem. So this stopped the research of neural networks for almost 20 years.